Hello students, this is Mr. Allen, and today we're going to look at two sections for the week. We're going to look at section 8.2, which is on special right triangles, and section 8.3, which is on trigonometry. Our objective here on the first section is to find the lengths of sides of special right triangles, and our second objective is to use the trigonometric ratios to find side lengths and or angle measures. So this is our first special right triangle, and it's what we refer to as a 45-45-90. It turns out that the reason we call it a 45-45-90 is because this angle is 45, this angle is 45, and then of course there's a 90-degree angle. Turns out that the length of the hypotenuse is just the square root of 2 times the length of any side. So for example, if I told you that this side over here was 7 units, then the length of the hypotenuse would be just 7 radical 2. So here's an example. So we have first of all, we want to identify that this is indeed a 45-45-90 triangle, which it is. So therefore, we know that the length of the hypotenuse, h, is simply going to be square root of 2 times 9. That's it. I mean, it's pretty easy. Now, if you want to figure out what the decimal approximation is for that, we'll just do 9 times the square root of 2. So it's about 12.73. Let's look at a different example. It says, what is the value of x? Okay, now this one's a little bit different. So to go from the leg to the hypotenuse, we got to times by the square root of 2. So if we're going to go the other way around, we just need to divide by the square root of 2. So x is just going to be 6 divided by the square root of 2. And hopefully you can remember that in Algebra 1 we rationalize the denominator. And so we will end up getting 6 radical 2 over 2, because square root of 2 times square root of 2 is 2. And that gives us 3 radical 2. So our answer is B. All right, the second right triangle we have, special right triangle, is what we call a 30-30-60. And the reason we call it a 30-30 or a 30-60-90 is the fact that it has a 30-degree angle, 60-degree angle, and then of course a right angle. So here's the rules that you need to know for it. If the bottom side is S, so if this length here is S, then the hypotenuse is 2 times S, and then the longer leg is S times the square root of 3. So for example, oops, erase all this. If we knew the bottom side again was 7, let's say, I think I'm on the highlighter here, then the hypotenuse is just 2 times 7, or what we call 14, and the longer leg is just going to be 7 square root of 3. It's that easy. So example 3 says, what is the value of D in simplest radical form? So they've given us, first of all, we recognize that this is a 30-60-90 triangle. They've given us the longer leg. So what we need to do, if we knew what D was, we would take that times square root of 3 to get to the 5. So this is kind of a harder one, just like the second example. What we're going to do is instead of multiplying by the square root of 3, we're going to actually divide. So it's going to be 5 divided by the square root of 3. That's what D is. And again, we're going to multiply by the square root of 3 to rationalize our denominator. Square root of 3, square root of 3. And so we get our answer here of 5 square root of 3 over 3. That is in simplified radical form. Now this question didn't ask us to do anything but find D, so technically we're done. But to find F, you would just take 2 times D. In other words, it would be 10 radical 3 over 3. So these are very easy once you learn these rules. Okay, so let's go ahead and move on to one applied problem. So here it says an artisan makes a pendant in the shape of an equilateral triangle. The height of each pendant is 18 millimeters. What is the length S of each side of the pendant to the nearest tenth of a millimeter? So the key thing to recognize here is since this is an equilateral triangle, each of the angles is 60. Now, since we have an altitude drawn here in the middle, that means that this is 60, this has to be 90, and then by our triangle angle sum theorem, we know that that has to be 30. It's a 30, 60, 90. We again know that the height here is 18, not 1.8, but that's 18. Sorry, that's a hot mess. Let me fix that. There we go. So to get this shorter side here, we're going to have to divide by the square root of 3. So this is going to be the square root of 18 divided by 3. And again, we're dividing because the formula tells you that if the short side is 7, you multiply by radical 3. So if I'm dealing, again, this is the long side, right? This is the long side. And when I should say the long leg. So we're going from the long leg to the short leg, so we have to divide. Again, we're going to multiply by the square root of 3 on the top and the bottom. That's going to give us 18 square roots of 3 over 3, which is 6 radical 3. And then to get the long side, we just need to take that times 2. So now we're just going to multiply this by 2, and we get 12 square roots of 3. And I'm going to go ahead, and since this says to give us to the nearest tenth of a millimeter, I'm going to go ahead and calculate that. And this gives me 20.8 millimeters. 20.8 millimeters. Okay, so that ends section 8.2. So now 8.3 is our main trigonometric ratios. They are known as sine, cosine, and tangent. Hopefully you've heard of those before. And to find the sine of an angle, you take the length of the leg opposite the angle divided by the hypotenuse. So if we're referring to angle A right here, we'll call angle A. Right here, we'll call that theta. So then the sine of theta is going to be the opposite leg. So that's A over the hypotenuse. The hypotenuse, remember, is always opposite the right angle. So that's why we get that ratio there for sine. Let's do a different one. Erase this stuff. Again, we're still using theta here. This is theta. So what is the cosine? What is the cosine of theta? Well, cosine is going to be the adjacent leg. Adjacent just means next to. So that's this leg, so that's B. And again, it's over the hypotenuse. Hypotenuse is C. So again, you can see where the B over C is. And then finally, last but not least, let's do this one in green. The last one in green. So again, we're talking about theta here. Tangent is the opposite leg over the adjacent leg. So that's A over B. So the tangent of angle theta is A over B. So those are our key trigonometric ratios. You want to keep this little chart kind of handy. So let's look at a problem here. Question 5. What are the sine, cosine, and tangent ratios for angle T? So here's our angle T. So the sine of angle T is simply going to be the opposite leg over the hypotenuse. In this case, that would be 8 over 17. There's our sine, okay? So it's the opposite leg over the hypotenuse. The hypotenuse is 17. All right, let's look at the next one. Let's do cosine. The cosine of angle T, that is going to be the adjacent leg over the hypotenuse. So again, if this is our angle T, this is the adjacent leg, and our hypotenuse is 17. There's our cosine of angle T. And finally, the tangent of angle T is an opposite leg over adjacent leg. So that's going to be 8 over 15. That's it. That's all there is. So you just use this table to get those ratios. Remember, ratio is just a fraction. All right. I think this is our last example. So I got one more for this one. So this one's an applied one. We can see there's this, notice that there's this little yellow triangle here. Hopefully you guys are familiar with the Leaning Tower of Pisa. In 1990, the Leaning Tower of Pisa was closed to the public due to safety concerns. The tower reopened after 2001 after a 10-year project to reduce its tilt from vertical. Engineers' efforts were successful and resulted in a 5-degree tilt reduced from 5.5. Suppose someone drops an object from the tower at the height of 150 feet. How far from the base of the tower will the object land? So let's just go ahead and draw our triangle here separately. So here we have our right angle. We know that this angle up here is 5 degrees. And we know that this height over here is 150 feet. And what we want to know, it says how far from the base. So this is the base. I'm going to call that x. So in this particular example, we have to figure out, are we going to use the sine ratio, the cosine ratio, or the tangent ratio? Well, in this particular case, we know this is the adjacent leg, and this down here is the opposite leg. So when we go back here and look, we got to use tangent. It has to be tangent because it's the only one that has the opposite and adjacent. So we're going to say that the tangent of 5 degrees is equal to x over 150. So basically what I did there, if the angle's 5, and then we've got the ratio will be the opposite leg, which is 5, divided by the adjacent leg, which is 150. In other words, x, I'm going to cross multiply, is going to be 150 times the tangent of 5. Now here's where we're going to need a calculator. I've got my calculator ready to go. So all I'm going to do, and there's a button that says TAN. You need to make sure you're in degrees, but you do 150 times the tangent of 5. Now guys, there's a lot of videos that will show you how to use your calculator. All you got to do is go search in YouTube for your calculator and just type how do you do tangent or trig or whatever, and it'll show you how to do it. In my case here, we have found that the answer is going to be 13.123. So this is about 13 feet. Oops. 13 feet from the base. So how far will it be if you dropped it from the top? It'll be 13 feet away from the base. All right, last example. This example, we're going to have to do the arc of the inverse of tangent, or the inverse of sine, or the inverse of cosine, to find an angle measure. So this is probably the most important one and the least intuitive of the bunch. So we're trying to figure out what the measure of this angle here, x, is. Now notice that x, based on x, we know that we have this is the opposite leg, and we know that this is the hypotenuse, okay? Down here is the adjacent leg. But we don't know anything about the adjacent leg. We only know the opposite leg and the hypotenuse. So let's go back to here. Which of these is the opposite leg and the hypotenuse? It looks like we're going to need the sine ratio on this one. So that's what we're going to do. So So we're going to say that the sine of angle x is equal to opposite, right, over hypotenuse. In other words, it's going to be 6 over 10. In other words, the sine of angle x is 6 divided by 10 is, I think it's 0.6. And now the question is what do I put in there to figure out what x is? So now instead of using the sine button, right above it is, on my calculator, it has a little sine to the -1. That means it's the inverse sine function. That's what we're going to do. So I'm telling you that the measure of angle x is equal to sine inverse of 0.6. Sometimes you'll hear it referred to as the arc sine. Again, you can Google how to do that with your internet. So now I'm going to do that. Right now I'm going to do the inverse sine of 0.6. And I get that it is about 36.868989, and it keeps going, but I'm going to stop there. So to the nearest degree, it's going to be 37 degrees. That is the measure of angle x. I think that is the end of our presentation.